Hello. In this lecture, we are going to demonstrate building a class uh, basically from the ground up while talking through the thinking of what we're going to work with. So what I'm going to do here in IntelliJ is make myself a new project, and I'm going to call this Car Class Demo. I think I'll leave the basic options checked here, and we'll go ahead and hit create. And sorry, my IntelliJ window likes to jump all over the place. Okay, so let's get our screen real estate optimized here. And so we see IntelliJ has written us just a little stub of a main method. And so the idea here is we're going to create a separate class file to model something. Um, I'm going to work with cars as my topic. Now, what I'm going to do is before I attempt to write the class, I'm going to plan the class out. I'm going to write something just in uh, a very basic form to kind of identify what I want my class to do. So I'm going to create myself a new file here just for some notes. All right, I'm going to do a uh, unofficial version of something that we use to basically describe our class files. So what I'm going to do is make a notation that I'm going to represent a car. The idea behind a class is that we can encapsulate data and methods about something that we're representing into one object. Okay, the class definition would then be instantiated in objects. And we keep the data together. We drastically reduce the number of variables that we're going to need. And basically, this is the foundation of object-oriented programming. So I've decided to use a car as my topic of this program. So I'm going to keep it very simple. I've decided I want to do a string of make. Okay, make is a characteristic or a property of the car that I'm going to want to track. That's going to be a string. So I'm just making notes. I'm not programming here. I'm going to want to store the model. And I think I'm going to want to store the size of the tank. We're going to use this for uh, developing a method that kind of makes sense. So we'll do double. Okay. So what I'm going to need is a couple of methods. We'll do a method that allows us to find the MPG. Okay, and then we'll do another method that just prints out information about the making model. Okay. Um, I might come back to our car notes because this is actually missing some stuff that I'm going to introduce in a little bit. But let's start simple and kind of get a basic program going. So what I'm going to do is going to make a new Java class, and I'm going to call it car. Okay. Java is, I'm sorry, IntelliJ creates us a new public class car, does not write a main method, and that's actually okay. That's a good thing. This class file isn't intended to be run by itself. It's intended to be run by a different class. Okay, so what I'm going to do is we'll start off very simple. I'm going to make a couple of variables to store these values. And bear in mind, I'm going to demonstrate something and then change this up a little bit. So just right here in my class, I'm going to say public string make, public string model, And public double. Oops. Okay, so three variables. They're not assigned to anything yet, but already we can demonstrate kind of how useful this is going to end up being. Over here in my main, what I want to do is change my initial text here. Okay. So I can instantiate my car already. Later, in a later lesson, we're going to discuss things like variable scope, class, where classes can be accessed. For the moment, if my car class and my main are in the same project here, I'm going to be able to reference the car class from my main. So to instantiate a new instance of my car class, I'm going to say something like car, let's say my car equals new car. Okay. So now already what I could do is I could say my car dot, and now my IDE knows that those public variables of tank size, make, and model are available and accessible to me. And I'm going to use my first car. I took that as a double, didn't I? So we'll write that as a double. Okay, so this may seem like a very minor thing, but already we have a very large benefit of using classes. I have three values that I am associating as being related to each other and as being connected to a single my car. I'm going to add a second instance. My car to make. To model. And then my car to okay. So what we see here is just with the very little work we've done so far, we can uh, represent a real world object like a car in a kind of logical fashion. Um, we have two object variables here, my car and my car too, and each one of those has these properties. You can almost think of them as subvariables, if you will. But by creating them in a class, they're all kept together, and I'm not going to accidentally confuse, uh, Ford and RAV4. These values are contained together in the car class. Okay, so I'm immediately going to break what I've just done as I think about it a little bit. Generally speaking, making variables public means that other programs that are using my class can modify those variables. And sometimes that's desirable. Other times, we want to protect those variables. We want to keep them uh, basically out of the user of my class's hands. So quite often, instead of making variables public, we would make them private. Okay, and I'm actually going to do this with make and model, and I'm going to break my program for a little bit. Actually, before I do that, we should run to demonstrate that we've actually done something interesting here. I'm just going to do a print line of, we'll just run my car make. And again, whoops. Oh. Notice that, holy heck, typo's taking me down. Notice that my IDE understands like the various currently public properties that I can work with. And it helps me stay organized. It helps me in a logical fashion know what variables are contained within that class. So let's just run this before we break it. Okay, so I printed out the make property of my car object variable that is based upon my car class. So now I'm going to break this program and we'll have to rewrite portions of main. I'm going to make and model private. Okay, and it's saying, oh, you've got multiple problems now. When those are private, only other code within the class is allowed to manipulate the make and model variables. Okay, so these lines right here are now problematic. Okay, we can't do this anymore. We're going to have to change how we work with the make and model values. And the way we're going to do this is we're going to create a couple of methods that we refer to as accessor and mutator methods, also known as setters and getters. With my accessor and mutator methods, the user of my class has to explicitly call a method that might have additional error handling built into it or some other logic to make sure that even if it wouldn't be a syntax error, you're making sure that whatever rules you have for the class can be applied. Okay, so accessor and mutator methods. Accessor is what I use when I want to read a value from the self-contained or protected class variables, whereas mutator or setter is when I want to update one of those values. So these can be very silly, not silly, I'm sorry, simple. Let's make a little comment here. Okay, so to read the values, what we would have to do is I'm going to do public string get make. If somebody wants to retrieve the make value, we're going to do a return of this dot make. So this dot means or references this particular copy of my object. This is kind of protected. It won't accidentally interact with other variables that might be in my program. Okay, we're self-contained inside the class and therefore protected. All right, I'm going to repeat this same process for creating an accessor method for model. So again, what we have now is these variables are protected from accidental change by something else that is using my car class. And the user has to explicitly call the get make or get model methods to retrieve the values. Next up, I'm going to write a couple of mutator or setter methods to allow the end user to put values into these. Okay, so we're going to do um, I'm just going to do public void set make and then accept string a string parameter. And then what I'll do is I'll set the internal variable equal to the argument that was passed. The argument that was passed into the M parameter variable. I'm going to do the same thing for the model. So now we've set up a mechanism to protect some of our variables that we don't want to be erroneously manipulated. But then we've also set up a mechanism for the end users to be able to update those values or retrieve those values. Okay, now this is meant that we need to change our main. Okay, so now if I want to update those values, I have to call a method. My car set make, and we'll pass it forward. Okay, so I can no longer access the variables directly. Now I have to call the methods. My car set model escort. Ditto for the, honestly, I'm going to erase this. It'll speed up some of the work we do every time I have to come through and make changes. Notice that I wouldn't do this in the real world. I intentionally left the tank size variable public so that we can compare, contrast the ways we directly access a public variable, or once we made things private, we have to use accessor or mutator methods to access them. If for some reason I had a value that I didn't want the end user to be able to access, I simply don't write a setter or a getter method. Either I could write one or the other, or both, or neither. So I have more control about how the end user gets to their value. I can no longer just say mycar.make, because that make variable is now private. It's hidden. Now I have to explicitly work with the getter, the accessor method, to retrieve that if one has been written. Okay, let's try running this again. Okay, I'm going to run main. Okay, and I was able to retrieve that value. Okay. Now, the next thing I want to do, classes will have what's called a constructor. Constructor method is a method that is called when the class is created, when the class is instantiated. Okay, so a constructor method would be run when I declare a new variable as my class, like I've done here on line 5. You can have multiple constructor methods if you want to. I'm going to do 2 constructor methods. And by the way, like you started to experience when you got into writing methods, I can write these in top to bottom. It doesn't matter the position I put this into. So I'm going to create a car constructor method. So a constructor method shares the name of the class. Okay, this is going to be known as a no-arg or a no-argument constructor. This would be the type of method that would be run if a user instantiates my class, creates an instance of my class without supplying any parameters. I really should say without supplying any arguments. Okay, I don't have any parameter variables here. And so with this type of constructor, what I could do is set some defaults if I wanted to. Oops, just a semicolon there. Now, I'm not saying you would want to do that every time. You may not want to allow a no arg constructor in any way, shape, or form. That's kind of your call. I'm doing it to demonstrate how I might make use of a no arg constructor. Again, constructors are methods that are called when a user instantiates, creates an instance of my class. So next, I'm going to write rather, an arg constructor. Okay, so a constructor with parameter variables, maybe allowing the user to supply the values at the same time as they instantiate. So that's what we're going to write next. Okay, so again, we're going to name the method the same name as the class. Now, right now, it's showing you an error because I'm talking. It's showing you an error because we are doing something called overloading, which you may have learned about as you learned about methods. Overloading is when I have multiple methods with the same name, and that is allowable. But the trick is they have to have a different method signature. So a method signature is either differing numbers of arguments or different order of data types of arguments, or a combination of the two. Right now, I don't have differing numbers of arguments because they both have zero. I'm sorry, I should have said parameters, but they both have zero parameters. What I'm going to do with the arg-based constructor I'm going to create 3 arguments so that the user, I should say the programmer, when they create a copy of my car class, they have the ability to supply the values immediately. So what we would do in this context, I would copy the values from the parameters. Okay, you may have noticed my odd parameter variable names. I like to try to be very clear about what is, an internal logically named variable versus a parameter variable. So I always, I mean, I could have used like, MMO something, but I like to be very clear when I'm writing my methods here, um, that something is a parameter variable. Okay, so to make use of my arg-based constructor now, I could come back to main and maybe we'll create a second instance. My car 2 equals new car. But this time, I'm going to supply some parameters. And I'm going to try to spell new correctly. Sorry about that. Actually, you know what? I want to do that again. Because I had misspelled that and didn't notice, we missed an opportunity to the IDE didn't autocomplete the way I was hoping. Oh, there we go. So the autocomplete, not autocomplete, but the IDE is providing me with tooltips because it recognizes what I'm beginning to build here. Toyota RAV4 and 15. Okay, so when I call my constructor with these three values, Java knows it needs to run this. And so those three values are going to be copied into the internal variables. Even though I will mention technically, because tag size was public, I could have still utilized this mechanism for my car too in order to change its tag size. Again, what I would probably have done in the real world would have been to make tag size private as well, so that I had to write an accessor or mutator method. Really just doing this for the video for demonstration so you can see the two different schools of thought. Okay, well, now we want to do something where we're going to write kind of a utility method. Again, a part of the benefit of working with classes is you can gather your data together, contain your data together. We say encapsulate. And then also the methods that go along with it. Maybe I'll write these methods down towards the bottom. I tend to write this is just a personal thing. I tend to write my accessor or mutator methods a little higher in the file, and then my utility methods, if you will, lower in the file. So what I'm going to do is I'm going to write two methods for us to experiment calling. So I'm going to say public, once again. So a public method will be callable from a different file, like main in our case. It's going to return a string. I'm going to call this summarize. Oops. And summarize won't need any arguments. What I'm going to do is return I'll return just a string of the make and the model concatenated together. So let's see what that would look like. Let's go back to main. And I'm going to work with my car 2 here. String value equals my car 2 dot summarize. Okay, so I'm going to then print that out. And let's run this and see what it looks like. That up a little bit. And this was the output from that particular thing. Technically, I didn't need to create a value variable. I could have just done this directly right here. I could have just done my car2.summarize, and that would have worked. Here, maybe we'll concatenate something in here. Okay, let's go ahead and run that. Okay, so we can see the updated text coming from my summarize method. Okay, I've written this to be as simple as possible, so we're kind of taking user input out of the equation, and I'm going to continue doing that. But let's say we had a desire to find the miles per gallon of our car. So I'm going to write myself an MPG method. or maybe we'll call it find MPG. Again, I'll call it public. Well, I'm not calling it public. I'll make it public so that other files like main can access it. And in a later lesson, we'll talk more about basically the scope that we're setting up, what can work with what. I'm going to call this find MPG. Okay, so I'm going to calculate range as range is how far can I drive on a full tank in my definition. MPG would then be divide range by the size of the tank. So okay, remember we were storing the tank size as a public property variable. And then I'll just return MPG. Okay. It's giving me a little message saying, hey, that's kind of redundant. I could have just basically returned the result of this calculation right here, but that's okay. I'm just trying to be kind of as clear as possible. So let's go back to main and see if we can implement this. So I'm intentionally writing that particular method in a way that is making use of both arguments that are passed into parameters and the internal variables of the class. So I might do double MPG equals okay. Notice once again the auto completes very nice here. Now let's see the range. I can drive 300 miles on a full tank of gas. So I should be very clear here. Well, let's run this and then we'll talk about what we want to be clear about. Okay, so it's telling me apparently I get about 20 miles per gallon. So once again, I was a little redundant by calling the find MPG method and then storing the value in a variable that I only use for basically one line and then printing that out. Just like we had demonstrated before up here, might have been a little bit quicker and easier to just do a print line of the direct method call, like I'm doing in the highlighted code that you're seeing right now. I also want to be clear. So this MPG is completely different from this MPG. This MPG is local to this find MPG method declaration. It doesn't exist anywhere else. And so another benefit of working with variable scope in terms of both method and classes is that I have an ability to reuse variables. More often than not, it's going to happen accidentally rather than intentionally. But by having the variables locked into their little rooms, you are less likely to accidentally misuse and corrupt a variable because you didn't realize somebody else had used MPG or something like, first name, last name, city, state, zip. Those are very common variables. Okay, so it is possible to write a class inside a file that also has a main that calls it. But although it was a little bit of extra effort, sitting down and trying to plan out what did we need to do to be able to get values into the private variables and out of the private variables. We had to, do some extra work to write our mutators. As a matter of fact, I kind of intentionally left that out of this preliminary list. Okay, we need to need to make a note that we'd have to write our accessor and mutator methods to get values in and out. But again, I could choose which of my internal properties, also known as fields, which of those variables I wanted to write mutators for. Maybe there's some that I don't want them to be able to manipulate. I could make an MPG, a private MPG variable, not write a mutator for it, and then say, oh, the only way to set the MPG internal variable is to call the find MPG method, and then it could maybe set that internal property that way. So I hope this has been helpful in trying to talk through why we're going to go through the effort of making the classes. And what's very nice, what I hope is obvious right here, is again, now instead of 6 different variables to represent the 6 values of Ford Escort 10, Toyota RAV4 15, and the likelihood of those getting confused, well, instead we just have, we can just access my car and my car too. And again, what's very nice is my IDE is now able to report public variables if I want to work with them, or it can report all the methods, including things like my accessors and mutators. So my IDE helps me work with the class a little bit better. And if I were to give somebody else my class, the class in any modern IDE, integrated development environment, would basically be self-describing. All right, I hope this video was useful, and stay tuned for more tweaks. We left a few things out of this video, but this is a good introduction. All right, have a great day.